Our last video introduced exponential functions. One of the many applications of exponential functions is calculating interest. So let's say you borrow $10,000 at 8% interest, and that is compounded one time a year. So after 1 year, what do you owe? So you borrowed $10,000, 8% interest, and after 1 year, that interest is calculated. So you'll owe $10,000 times 1.08 because you still need to pay back the original $10,000. That's times 1, and then the 8% interest is tacked on. This would be $10,800. Let's suppose interest is compounded more than once a year. So if interest is compounded 2 times a year, you will owe the following. So you're still going to wait 1 year, but the interest is calculated twice. Once at 6 months and one at the end of the year, let's say. So you borrowed $10,000. You're borrowing it at 8% interest. So if you compound the interest halfway, then you're going to have 4% interest twice. If you do this calculation, you may notice I have 10,000 times 1 plus my interest rate, which is 8%, 0.08, divided into 2 parts, because I'm compounding it twice a year, twice. And if you do the calculation, you'll get $10,816. Let's say if interest is compounded quarterly, 4 times a year. You owe, after 1 year, $10,000, and then you're going to divide the interest 8 into 4 pieces and multiply by that value 4 times. So I think I'm going to get 1 plus 0.08 divided by 4 to the 4th power. And if you do the calculations, I think you'll get $10,824.30. You can compound interest even more times. So for example, if interest is compounded daily, you owe, at the end of 1 year, $10,000, 1 plus 0.08 divided by 365 days of the year, times 365 power. That's the exponential function we've been talking about. I'm raising a number to some power. That is $10,832.80. And I think you'll find that if you increase the number of times that you compound interest, so you can go from once daily to twice daily to 1,000,000 times a day, this number will not get larger and larger and larger. This number here will approach a single value. In fact, if interest is compounded 1,000,000 times a year, I believe this number only changes to $10,832.90. It only goes up by 10 cents if you compound from 1,000,000 times to daily. Anyway, we're going to think about this idea more closely But before that, let's say a more general formula for what I'm doing here. So if you borrow $, so A is my 10,000 in this example, at a rate of R annual, and it's compounded N times a year for T years, then you will owe the following: A times 1 plus R divided by N to the NT power. So I hope that you can kind of see where this formula is coming from our previous example. I have a certain amount, that's like the 10,000. I'm dividing the rate into a bunch of pieces because I'm compounding it many times a year. So that's my rate divided by N, like this 0.08 divided by 4 or 365. I'm raising that to the N power, and then I'm doing that for each year T. So I get a sort of exponential function here. Let's finish this example, or this video, with an example, and then we're going to continue thinking about this idea of compounding interest more and more rapidly in our next video when we introduce a very important number, E. So let's say we borrow, let's say you're trying to buy a home, and you've saved up a bunch of money for a down payment, but you still need to borrow some money. So let's say you borrow $400,000 at a rate of 3.5% interest annually, and they compound it daily. And let's say you want to understand how much your monthly payment would be in interest alone. So you borrow that amount of money at that rate, compounded daily for 1 month only. If you do that, after 1 month, you will owe $400,000 times 1 plus 0.035%. So 0.035 divided by, it's compounded daily, so I'm going to divide by 365. I'm going to raise that to the 365 power, and I'm only doing this for 1 month, so 1/12. And if you do that calculation, you will find approximately $401,168. So after 1 month, if you borrow this amount of money to buy a home at a 3.5% interest rate, then just in interest alone, you'll be paying $1,100 about. If you actually buy a home, of course, you need to pay down principal each month. So that would increase this payment. And also taxes and insurance. You could expect this amount to double or even more if you're trying to buy a home with this amount of loan. Let's see what happens if you change the interest rate. This is one of the reasons why people are so fanatic about getting a good interest rate. If you change the interest rate, of course, it changes the amount you have to pay each month. So let's say you borrow the same amount of money, but you get an interest rate of 7%. And you compound daily for 1 month. So at 7% interest, so I'm doubling the interest rate. Will I double the amount of interest I have to pay? Well, let's see. So $400,000 times 1 plus 0.07 over 365 to the 365 times 1/12 power. If you do this, you get approximately $402,340. Again, this amount is just an interest. If you actually borrowed this amount of money at 7% to buy a house, then this amount you could expect to go up significantly because you'd have to pay down principal and also taxes and insurance. So this is why lower interest rates allow people to buy homes for larger amounts, because the pay is dramatically increased if you just simply increase the interest rate by a small amount. Okay, wonderful.